Hi, I'm Michael Cioni. Anyone building a modern post house knows that you have a type of preference, and your preferences are going to have some sort of dictation in terms of the equipment that you put into the facility. Now, I can't admit that there is one perfect or single way in order to develop or build the most efficient post house, but I can admit there are good ways and then there are poor ways, even though both of those might come together to achieve the same goal. In this case study, we're going to take you a little behind the scenes of Light Iron into our architecture and show you how we're preparing for the post-production needs of tomorrow. And here's one of our secrets. If you want to prepare for the post-production needs of tomorrow, you shouldn't do it based on the benchmarks of today's norms. For example, if you plan on doing most of your work in 2K, then building a 2K infrastructure around your projects is not enough. Likewise, if you planned on doing UHD or 4K, then a UHD infrastructure is no longer enough. The Red Company recently released a new camera called Red Dragon. Dragon captures images as high as 6144 by 3160, over 19 million pixels per frame. So in order for anyone to have an optimized and efficient plan of managing, moving, manipulating, and monitoring that information, even a 6K infrastructure as of today isn't enough. So in preparation for Dragon's release, in 2013, Light Iron began designing a system that, in theory, makes the management of 6K material behave just like it should in 2K, which, by the way, is 9 times smaller. We believe you cannot value any camera system exclusively based on the images it creates, nor can you just base it on the way the mechanics behave on the set. You have to also take into consideration how it works in post. So, if the alluring 6K images of Dragon actually create significant penalties in post, then the most noteworthy properties of this camera will actually go underutilized. So how does one ensure that the performance of 6K material is actually going to behave the way you would expect it in 2K?
When we redesigned Pablo Rio to work off commercial, off-the-shelf hardware powered by the NVIDIA multiple GPU technology, we knew that we were designing a system that our customers wanted to use way into the future. We knew 4K was around the corner, but we looked further beyond that, and 6K and 8K were obvious choices, building a system that would be able to handle that with the same ease of HD and 2K.
For NAB 2014, Red asked Light Iron to do the conform, color, and mastering of an end-to-end 6K short film called Closed Set. This case study is just an interpretation and a demonstration of Light Iron's tools and techniques that we deploy in order to make sure that 6K can move efficiently through the process, and even though they're 6K files, we're never falling victim to any of the standard file bottlenecks. Importing. Fitting entirely in only 4 full-size racks, Light Iron's DI mainframe is perhaps one of the most advanced in the world. At the heart of our infrastructure is the latest system by Quantel, the Pablo Rio. The choice for Rio came after 6 Pablo systems because it's the only DI tool that combines import, conform, editorial, color, beauty, effects, and multi-user sharing on a single kit. Running on custom-built supermicros, the Rios are connected to expansion chassis that enable us to have I/O connections to virtually any drive that contains source data. A DVS and Cubics expansion chassis allow us to add 8 different PCIe slots, which we typically use for increasing compatibility directly with drives of all protocols. Frames for any conform are typically consolidated to a single volume. For the best performance with Dragon, Light Iron uses custom-built shoeboxes equipped with SAS ports that deliver up to 500 megabytes read per second to a Pablo Rio. These frames are conformed in the Rio Conform tool and can be either soft-mounted as R3Ds or converted to uncompressed frames in Redlog film. Playback. One of the most challenging aspects of 6K DI is simply being able to play back frames. Once rendered, frames automatically become uncompressed files in 10-bit or 16-bit. This can be directly from a rendered color effect on an R3D, or a visual effects shot, or even the application of a title. At 6K 10-bit, Each frame of Dragon is 75.5 megabytes. 24 of those frames means sustained playback must maintain 1.8 gigabytes per second. So challenge 1 is building a drive array that can handle 1.8 gigabytes per second. But as I mentioned before, failing to exceed those specs will dramatically reduce overall performance, especially as disks fill up and multi-user work commences and cameras continue to improve. One of LightIron's favorite aspects of working with Quantel is their genetic engineering system, or gene pool. Gene pool is a highly optimized disk array that not only provides future-proofing through advanced performance, but also allows each Rio operator to dynamically share their work across all the systems on the gene pool itself, completely render and transfer free. Our gene pool is made up of 96 2.5-inch, 900 gigabyte, 10,000 RPM Hitachi drives. Governed by an advanced hyperspace controller, this ultra-high performance data engine provides hours of total storage in 10-bit 4K content with 8 gigabytes of total throughput per second. That means we can simultaneously play 4 streams of 6K 10-bit material or 2 streams of 8K 10-bit material.
We designed Pablo Rio with an 8K infrastructure in mind, not because people were asking us to do that today, but because we can see a future where that becomes the norm.
Furthermore, with Gene Pool, colorists can work in tandem with other artists working on visual effects such as wire removal or titles while concurrently sharing the same timeline. Monitoring. The Red Dragon camera captures 6K images, but monitoring in 4K is still a developing technology. It is my belief that 4K monitoring will be a long-lasting plateau, even as cameras capture higher and higher resolutions. This is to say, investments in 4K monitors are a safe investment because 4K viewing will be the most common viewing platform for broadband and cinema for the next decade. At LightIron, the Rio is connected to one of the most advanced video cards on the market, the AJA Corvid Ultra. This box is designed to handle 16-bit 4K at 60p with 2 additional 4K expansion slots. AJA's TrueScale technology ensures perfect scaling and gives multiple 4K outputs, including Quad 3G with embedded audio. The Quad SDI is fed to a Christie CP4220 4K projector. The 4220 is a major part of the LightIron workflow because it's one of the few projectors that allow you to view DCPs through an IMB and simultaneously have an SDI feed with video without having to change your boards. It also has an eSATA and USB port, so you can load clips directly into the Christie for easy playback and QC of 4K DCPs without the use of an external 4K cinema server. Audio is de-embedded from the SDI stream using HD links and fed to our Dolby calibrated surround sound audio monitoring system. Inside of Rio, Dragon files live inside a 6144 by 3160 timeline, since Rio is resolution independent. Designed to work with files like this, Rio doesn't require us to create proxy files or down conversions. Rio and Corvid together provide a perfect 4K scale to our 27-foot scope screen. Coloring. With 19 million pixels per frame, it is imperative to LightIron that our clients don't get the impression that shooting on Dragon 6K means you have to wait to see the results. The new Pablo Rio system is based on GPU acceleration, which allows us to upgrade our performance without relying on upgrading the core computer. Running inside our Rios is the latest NVIDIA Kepler K20 cards. By threading 4 of the Keplars together, Rio has almost 10,000 CUDA cores producing 14 teraflops of processing power. The practical results of this on Dragon material is that 5 layers of color correction with blurs play back in real time with 10% headroom still left over.
The speed that we get off the GPUs are way in excess of what we were getting on the previous hardware. In fact, just one of the Kepler K20s super exceeded 4 of our previous hardware cards. And the fact is that as the GPU technologies continues to advance, it allows our software to operate even more interactively with large file sizes.
To the client, colorist Corinne Bogdanowicz wants Dragon material to color fast, and with this design, frames play back without a Rocket X at full scale with virtually the same performance as if they were 1080p. In fact, The end title card for the closed set was actually an 8-layer lighting effect composite done in 6K on the Rio. Rio was able to render out the effect of those 8 layers at 12 frames per second. With this architecture, Light Iron is prepared for 8K real-time color with multiple artists working in tandem on the same material. Exporting. Once all the creative steps are complete, the last stage is exporting. At Light Iron, CTO Chris Pariseau designed our mainframe to separate all DI storage from a dedicated export volume, which we call Mercury. Mercury is 300 terabytes of a storage generally used for making outputs and different versioning. By separating your DI volume from an export volume, you can have 2 different departments share information without affecting each other's bandwidth. This is increasingly important with 6K files. This increases turnaround speed and eliminates performance hits on color sessions. Mercury is built using 96 4-terabyte drives and has nearly 300 terabytes of storage with close to 4 gigabytes per second in performance. Tied to Mercury over 8 gig fiber, Rio is able to export all the Dragon 6K material in real time. So there's the tools, that's the technology, that's the techniques we put into trying to make this 6K move really seamlessly. Now, I don't want there to be a misunderstanding. We're not trying to say this is the only way you can do 6K, but this is a way that we're really comfortable with and we're able to move these files through with relative ease. But 4K may be something people get tripped up on, or 5K or 6K. It's not about how many Ks there are, it's about high fidelity. Because outside of resolution, which is important, you also have to add in bit depth and color science and dynamic range and even HFR and things like that. And the truth is, it's our obligation to be able to respond to creative people who want us to push the boundaries. So if you feel that 4K is something you don't need today and 6K is way off, that's okay. But the mistake you would be making if you didn't start building a roadmap is when it catches up to you, you're not prepared. So I encourage you to take advantage of roadmaps that allow you to prove out your ideas so that when creatives start asking for this stuff, you're able to respond with a yes, I can provide this. And we just proved that with 6K content, uncompressed, that can move end to end through a post workflow based on technology that exists today.